Hello and welcome to Flotilla update number 37. We're going to take you through the final 4 modules. We've got one of each of them here today. Phil's going to run a demo of Rockpool, so we're going to have a little play with these modules and we're going to take a look at the dock. The big news on the dock is that we're expecting the PCBs within 10 days. So as soon as those arrive, this is the production PCBs, we can start assembly.
Yeah, that's 10 days as well, not 10 working days. So it includes weekends.
10 days.
Yeah. Saw Connor at Derby make fair and made him feel quite guilty, I think.
Did you?
Yeah.
Oh.
Yeah, Connor a ragworm. Lovely guy. We must punish him.
Okay, let's go.
Right, so 4 modules are dial.
It's not
Lovely,
quite
lovely
so
dial.
sparkly under this light.
Yeah.
Oh, there you go.
Oh,
yeah.
there we
Just
go.
bring it a bit further back, Phil. You're blurred up there.
Whoa,
There you go.
I can't hold my hands.
So the dial is basically the same kind of functionality as the slider, but obviously in a rotary dial. We've had the caps made to match the PCB colour, which is nice. This uses the same PIC chip that the slider and the joystick use.
Okay, and it's very cunningly hidden, so
Yeah, hidden underneath the actual dial package,
won't find it.
which is quite nice.
Yep.
But these are great for doing interfaces. We use this again on the instrument kit, I think.
Yep.
And obviously for things like volume control or brightness control, stuff like that's perfect.
Very familiar stuff. And if
Yeah.
you see the fading of the LEDs there, it's just quite nice.
Yeah, it's a nice little module, this one.
Because you've got a microcontroller on there, why not make it do
Why not?
something?
Absolutely.
Mm.
Yeah, you put those with sliders and the touch with the LEDs on there, all kind of together, and you've got a lot of stuff going on.
Your own
It's
custom
interesting.
control surface as an internet DJ.
Yeah.
Yep. And then the next one up will be
Motion. We haven't really talked about motion at all, and this
Right.
is the actual final version of this board does have a silk screen on, but we're still waiting for those PCBs. But obviously, this is a really useful thing. It contains an accelerometer and a
compass.
magnetometer.
Yeah.
So great for putting on things like robots so they can determine which direction they're facing, as in are they going north, are they going south. Also for detecting pitch, so if the robot's climbing a slope, you can tell how steep that slope is.
I've actually had some success rubber banding this to the top of a wheel and creating like a little self-balancing wheel robot. Which is
Yeah,
really cool.
you were doing that at Leicester Creative
It
Fair,
didn't
weren't
quite
you?
work as well as I expected there, but I've had it working really incredibly well. So you turn the wheel slowly around, but the sensor would remain upright. It's basically self-balancing. Hopefully that'll scale up to a self-balancing robot, but
Yeah.
you don't know until
I
we
think
try.
you call it a compass on Earth, don't you? But then a magnetometer if you're putting it in space.
Do you?
Because the actual specifications for the chip go into incredible detail about mentioning kind of local gravity and things. Because obviously, if you send this to another planet, you're not going to get the same readings. So it's very careful to just explain that it's the local magnetic field.
Yeah.
It's quite
I
strange.
suppose you've got
isn't it, really?
interference as well.
You're designing a product and you go, by the way, it's not going to work on Mars.
But they're really good. They say it will work on Mars. Just, local magnetic
scale your
field.
threshold slightly.
Yeah. A lot of iron on Mars. Surely it's got a really good magnetic field.
Yeah, it's a nice module to use for slightly weird interfaces as well, like as an input, similar to a Wii Nunchuck controller or whatever. So yeah, there's some real scope for doing interesting
set up at
things.
Leicester driving a robot as well, and it was
Oh yeah, the kids
odd
like tilting
because
it.
you had to figure out exactly what the relation of tilt was to the direction of the robot. So
Mhm.
it's a
That's
bit of a
why we
mini
need
challenge in
the
itself.
arrow on top.
Oh, maybe you go forwards. Oh no, it's going backwards. I have no idea what I'm doing.
Okay, next
Cool
up.
module. We've got the
Matrix.
Matrix is awesome. This is lots of good fun. Have you got it wired up to the dial at the moment?
Got it wired up to the tilt sensor actually.
Oh, there you go. So in this mode from Rockpool, we're just telling the Matrix to display a number, and Phil's got the motion sensor outputting a number into Rockpool. Rockpool's then passing that back to the Matrix. But obviously the Matrix, through the API and other mechanisms, can display any 8x8 image basically. So it's kind of cool for doing interfaces. We do a Pong game with this where we have 3 matrices, and that's the Pong board, and then you have a slider at each end for the user to control.
Yep, and in the same way that the slider and the dial are very similar, the number module and the matrix have the same underlying chip. And yeah, we just drive that with 2 different addresses in 2 different ways, and 2 different modules with very different applications. But who doesn't like a nice matrix?
No, definitely, and you could put kind of 8 of these on a single dock and do scrolling message displays and stuff, which is pretty
Or
cool.
little smiley faces.
Yeah, it's a nice module. Matrix is cool. And then the last one we've got here is the
Light
light
sensor.
sensor. This is part of our kind of weather station stroke environmental sensors set.
So I've got that reading the light level out onto here at the moment.
Okay.
And I've got a source of light here.
Oh yeah, there we go. Cool. So you literally just remapped it in Rockpool?
Yep.
It's that simple.
Let's bring up Rockpool as well so you can actually see the mappings there. That's not Rockpool. That's us.
Turn these off.
Looking
so
mystified.
Woohoo. So it's that rule right at the very top, which is just taking the input from the light sensor and mapping it straight out to the number. We do silly things like go in and invert that.
So Phil's put an invert filter into the centre of this rule. So now when it's bright it shows a low number, and when it's dark it shows a high number. And obviously we have a lot of different styles of filters, so we could try, I think, is there like a clamp?
Nope.
So now we've got a toggle in there. So basically every time it sees light it toggles on, and then when it sees light again it toggles off. So with all these kind of rules and features, you can create all sorts of different systems that behave in different ways.
Yeah, your project might require one of these, whether it's a doorbell or whether it's something else. One of these functions will probably give you what you want, and it's a very good way of looking at digital systems and looking at interfacing and how to turn raw data into something useful for your project.
Yeah, do you want to take us through some of the rules in Rockpool, Phil?
Yeah, as well. We've got a few modules hooked up, so let's get rid of everything for starters.
So for just completely to start with, obviously we've got a Flotilla dock here, we've got 4 modules connected to it. Looking at them, we've got three inputs and 1 output, though actually the LEDs can be used as an output on the dial as well, but in the Rockpool setup they aren't. So on the interface, what are we looking at here? Do you want to change this around so we get the interface big and small?
Small.
Yeah, we can do that. Yeah.
You can hide down below the interface.
There we go.
Interfaceception.
Okay.
So the premise of every rule is that you have an input, some amount of conversion in the middle if you want it, and an output. So we'll start by taking an input, and let's pick.
So here we've got a mixture of things. We've got kind of almost fake inputs, or things like keyboard events, right?
Yeah, it's worth pointing out the patterns. Now our heads are in the way.
Let's get rid of our heads.
Yeah. So we have this set of virtual inputs, like a sine wave or random pulses, square waves, triangles, saws, and a clock, which is just like a rapid toggle on and off. And these virtual inputs
We'll have a look at how it behaves.
give you a signal that you can then map to something, so you can have an output being driven without having any input signal. And they're also useful for toggling things on and off and kind of mixing with your input signals to do kind of weird and imaginative things. I think you mentioned it would be interesting if you took the sine wave and you had a game where you had to keep your wave exactly in line with the sine wave.
Oh, where you so you turn the dial to try and match what
it
the sine wave is doing,
so
essentially.
stick a sine wave in there, and let's get our dial in there as well. So we'll go and stick a converter in, and I think we want difference. So we're going to take a dial, which is over here.
Oh, I see where you're going with this. Yeah.
So now you've got this second output, which is the output of the difference between the sine wave and the dial.
And I'm turning the dial to try and track that sine wave at the moment. And the better I do, the less output we're going to get.
So if we say toggle actually detects anything that goes above the center point or threshold, but we could also do that with a percentage value. So if we say, what would it be, max of your output and analog value of 50%, I guess.
So what's going to happen
So that's
here?
going to go over. That may not be the best way to do it. There's got to be a better way to do that. Here we go. Greater than. If your output is greater than 50%, so do horribly wrong, and it will toggle on and say, you failed.
So that's almost like the buzzer on the old buzzer wire trick, right?
Mm-hmm.
So we go and map that out to a number, because that's the only output we've got now. Then when you fail, this will go straight the way up to 9.
Should we see what happens? Shall I fail?
Yeah.
Boom. There it is.
So you can imagine
Brilliant.
mapping that to a red light instead. So someone has to try and keep up, and you can make it harder and harder by taking that second 50% input and saying, well, actually, you're going to have to do better than 30% difference.
Oh, come on, don't be mean.
Well,
You could actually, instead of putting in that percentage, you could even put a slider in
Yeah,
and like
just
have
set
someone
the
control the
rule
difficulty
dynamically.
and someone else play the game, essentially.
So-
That's kind of cool. A couple of very basic rules, and you've got,
Gameplay.
yeah.
Yeah.
It ain't Doom, but it's interesting. I quite like it.
But you're learning about very simple principles here. This is
Yeah.
how you learn what's interesting and what's alluring.
Look, we pick very generic names for what these converters actually are, but effectively they translate in some ways to logic gates. So greater than is actually a comparative,
comparator,
making a
right,
comparison between two input signals and telling you when one's greater than the other. And difference is giving you the difference between two signals. What would be the electronic equivalent of that? But
Point
we've
out that
also-
I'm pretty awesome at this. Just
Damn you!
oh no!
Yeah.
We're going right down to 10% now, are we?
20 is the
Oh,
next.
he's not a mean man. Not unreasonable, are you, Phil?
Oh.
There we go. There you go.
Instant fun.
Yeah, it's cool. Phil does most of this software work, so some of this stuff is kind of quite new to Paul and I. And yeah, it's interesting.
Yeah. And that's where we are now, really. Most of the modules are in, we're waiting for the dock motion and a couple of other production modules to have their first short run. We're waiting for the platform and the box to come in before we can pack some packaging. So in the meantime, it's now working on software really and bringing this up to what we want to deliver to you as version 1, such that you can do all the things we said you do in the Kickstarter campaign. I think Rockpool's kind of core to that because it's new, but there's also things like the Scratch, the Internet of Things, the cookbook that we've got some stuff for, but now we've got final versions of most things. We can actually polish it off and get it ready for shipping out to you as soon as we can.
I think Scratch will be one of the more interesting ones because obviously there's now a new Scratch,
Yeah,
which
Yeah.
we've potentially got more opportunity to tweak. And
it's a lot faster.
there's been rumblings of having actual modules being created on the fly, which lends itself very well to Flotilla, of course.
Yeah.
To be fair, we did poke them about that, didn't we?
But so hopefully,
So, can we have this?
at
Can we
some
have
point,
this?
we will get a very tight integration of Scratch and Flotilla. But at the moment, when you're playing with Scratch and you're interfacing with hardware, it's a little bit airy-fairy that you have to kind of send control signals out to the hardware, and it's a bit fudged together. So
Mm-hmm.
Yeah,
one day
but-
we'll hopefully get a much better integration of the two.
It'll work. You'll be able to do stuff like this. Let's do good stuff with Flotilla, so that's all right, isn't it?
Mm-hmm.
That's all we want. Being able to demo it in the classroom in a familiar way.
Yeah. I think for the next video update, we'll put together a couple of nice projects, kind of using modules from across the whole range.
Well, that's what underlies the cookbook, isn't it? So
Yeah.
yeah,
Uh,
might as well do that. Right.
Yeah.
That's everything, folks.
that's what we've got for you this week. We'll
Speak
see
to
you next time.
week.
Bye-bye.
Bye.